All right, I didn't get time in class to show you an example of a function that isn't one-to-one, and I give you a homework problem where you're supposed to develop an example for a function that's not one-to-one. This one goes from R2 to R2, and it's not going to be one-to-one. So again, like the other example I did in class, t of x1 comma x2, the vector, is equal to x1 minus x2, x2 minus x1. So inputs are two-dimensional vectors, outputs are two-dimensional vectors. Now, I already told you it was not one-to-one, but if it were one-to-one, when the t of x is equal to t of y, it should result in x equals y by definition. So if I go down a little further and just plug and chug, t of x is this guy, t of y is this guy, and that gives me two equations if I set components equal. So x1 minus x2 is y1 minus y2, and x2 minus x1 is y2 minus y1. Now I just kind of guess and test to make the left side equal the right side, but not be the same values for x1 and y1. So I try to use zeros and ones because they're easy. So I plugged in 1 for x and a 0 for x1 as 1 and x2 is 0. And then I asked myself, how could I get 1 on this side? Well, I could have y1 equals 0 and y2 be minus 1. Once I made those choices, I just checked whether equation 2 works out. Equation 1 works out because I set it up that way. So x1 minus x2 is 1 and y1 minus y2 is 1. But equation number 2 worked out as well. I got x2 minus x1 was minus 1 and y2 minus y1 is minus 1. So they're equal on both sides. However, my x didn't equal my y. And so now I have a concrete example of a vector, two vectors where the y values, or the t of x equals t of y, were equal, but the x was not equal to y. Hope that helps. Let me know if you have questions.